Hello everybody and welcome to today's webinar. Thank you so much for joining us. Thank you for everybody that logged in early. I hope you wasn't waiting too long, but we are going to get started now. And for those of you who did log in early, I hope you had a chance to check out the sponsors' websites. This webinar is brought to you by Redgate and Enkitec. So today's session is on reducing downtime using incremental backups and X-Platform TTS, and the presenter is Martin Bach, who's the practice director at Enkitec. Once again, thank you for joining us today. So as I've just mentioned, the main presenter will be Martin Bach. You can follow Martin at MartinDBA. If you're on Twitter, please do follow Martin. Some of you may know already Martin's an Oracle ace, a member of the Oak Table, and a practice director at Enkitec. I'm James Mercer, as always. I'm part of the Oracle Tools team at Redgate, and I'm the creator of all things oracle.com. You can follow me if you're on Twitter at jmertz. For those of you who have come to sessions before, you may have noticed that I've just changed my Twitter handle. I thought it was about time that I had one more closely related to my name, so the only one that I could actually find that was appropriate, as a lot of the JMs and the James Merters had already gone. So if you're on Twitter, please do follow me. Of course, if you follow me already, then you may have noticed this. So before we get going with the main presentation, everybody will mute for the duration of the event. If at any time you can't hear us, please do let us know via the questions panel. Of course, please do check your own audio settings first. Also, if our sound does go a little bit strange, bear with it. It might be due to bandwidth, but if it continues, please do let us know. There will be a Q&A session at the end, but please do type questions in advance, particularly as Martin covers topics that you want a little bit more explanation about. Just type those questions in the questions box in your control panel, but we won't answer those questions until the end of the webinar. A full recording of this webinar will also be put up online. As you've registered, I will send you an email, of course, to let you know when this is available to watch. Hopefully I can get it up in the next couple of days. Once again, this webinar is brought to you by Redgate and Enkitec. So just a little bit about Redgate. So I obviously work for Redgate. We're a company, a technology company. We produce tooling for lots of companies that you've probably heard of. So there's some of the logos of the companies that buy our products on the screen now. Over 600,000 professionals worldwide use Redgate software, including 93% of the Fortune 100 companies. In terms of what we do for Oracle teams, our philosophy across all of the tools that we produce is to produce highly usable and reliable tools that solve pretty complex problems, but in a really nice and easy way. Our focus within our Oracle tooling is to make deploying Oracle changes easy. So delivering those changes from development through to production. We want to make that really, really easy. Our main tool set is called the Deployment Suite for Oracle. You can see the three tools we've got there: Source Control for Oracle, Schema Compare for Oracle, and Data Compare for Oracle. Please do check those out. You can find out more information at redgate.com/Oracle. And you'll see that what we're really trying to help you do is, as you're making changes, source control those changes, and then using our other tools to help deploy schema and table data. I'm pleased to be hosting this webinar with Enkitec as well, as a company that I've worked with on a number of sessions. You may have joined the sessions by Kelly and Pert Vaughan. If you don't know about Enkitec, Enkitec's a global systems integrator with a focus on the Oracle platform. Check out the website. There's a load of people that you've probably heard of and seen at webinars working for them. They're an Exadata specialized partner, one of only a handful of these companies globally. And as you can see here, they've successfully implemented Exadata over 200 times. They have a dedicated in-house engineered systems lab, and additional practices include Oracle RAC implementation, Oracle Golden Gate, Oracle application administration and on-call database administration. We've got some top experts there working for Enkitec. Once again, please do check out the website www.enkitec.com and you can read a little bit more about Enkitec there. Okay, so I'm going to pass over to Martin now, who's going to take control of the screen and the mouse and go through the main part of the presentation. Please do bear with us if there's a little technical delay as I hand things over.
Okay, hello and welcome everybody to this session hosted by Redgate and Enkitec. The topic today is one of the ways of reducing downtime using incremental backups and cross-platform transportable tablespaces. That's what these acronyms or the abbreviations stand for. My name is, like James said, my name is Martin Bach. I'm a practice director at Enkitec over here in Europe. One of the things I would like to add to the previous slide about Enkitec is that we have consultants with an average of 15 years of experience on Oracle, and we've got lots of consultants with lots of experience on the Exadata platforms. And what I'm especially pleased about is that we entered the European market in 2011, and we have already been recognized as a leading engineering systems partner by the UK OUG. So that was the little icon you saw on the top right, on the bottom right of the screen. Okay, so let's carry on and say a few words about myself. So I work for Enkitec, obviously. I have played with Oracle 11G Rack a lot and 10.2 and previous versions, and during a UK OUG user group meeting I have been invited by the authors of the 10G Rack book to help them out on the 11G Rack book, and I was immensely pleased for that to happen, and we put the book out, and this is where I contributed by putting this to paper. I'm even prouder to be an Oak Table member. I'm also an Oracle ACE certified master, and I do blogs. So if you search for me, my blog is martincarstenbach.wordpress.com, where you find things about my research and what I do and what I find exciting. I haven't put this talk up onto my blog because I wanted to save it for the presentations that I'm going to do. So what I would like to cover today is first, why would you bother with incremental backups and cross-platform transportable tablespaces in the first place? I give you a few facts and trends that I have observed in my career over the last 10 years, and especially about the time from 2009 to up to now. I'm going to explain to you how I have done cross-platform migrations in the past, where we migrated from big-endian to little-endian. I'm going to explain to you what I think is a reasonable modern way to do the same thing with less effort. And if the demo gods are with me, I'm going to also display the steps on my laptop in a few virtual machines for you to see that it actually does work. Okay, so the first question is why would you care, or why you should care, in my personal opinion. I suppose I see 187 attendees right now, so there are quite a few people online that do actually care how to do cross-platform migrations, and the following slides I'm going to talk about why that might be the case, or it's in my experience. So some trends and facts that I have observed over the last 5 years, let's say. When I started IT in 2002 at university, and I took it a lot more seriously than before, the established platforms that I was allowed to work with at university, they were usually based on SPARC processors running Solaris. They were IBM power processors running AIX. And there was a lot of HPUX titanium, at the time PA RISC, of course. And these platforms were what we considered Unix. And there wasn't an awful lot. Finally, Linux emerged as a new platform to be taken more seriously. But it wasn't at the time that the enterprise distributions as we know them today from Red Hat or SUSE or Avionics and all the other derivatives of those were established. So basically what you had was a user distribution consisting of 6 or 7 CDs that you had to install single-handedly, and it took quite a while. And these distributions made it difficult for enterprise software vendors to provide support and also a common installation package for software such as Oracle. And I remember when I first installed Oracle on Linux, I had to manually go through the make files and change those to ensure they actually compiled with the compiler that was on the system. Nowadays, the situation is quite different. There are lots of enterprise Linux distributions to choose from. Probably the most important ones would be the Red Hat and Red Hat derivatives, such as Oracle Linux, Scientific Linux, and CentOS. But back then, it was proprietary systems that you could not easily get your hand on, and you couldn't easily buy one of these systems as a student. But ever since these days, it seems to me that these platforms have been losing market share. This is especially true for the HPUX platform, unfortunately, which is a great platform, but some decisions that have been made by top management in some companies have brought HPUX to the point where people are just moving off. And this will become significant later because of the way that data is internally stored and coded on the platform. Similar SPARC servers are in decline as well, and P-series, but to a lesser degree. So these systems have been losing market share. There are a number of reasons for these, but one of the blogs that I recently read said, well, the author of the blog stated that lots of workloads that have been traditionally run by these rock-solid Unix platforms have been taken over by industry-standard components. I say industry-standard components because I don't really like the term commodity hardware. Most of those, however, are run in Linux. The other main competing platform would be Windows, but in my experience, the database workloads that I have been seeing in my career, they're not really Windows-based. Most of them really run Linux. This is especially true for smaller companies where budget is tighter, and this is probably one of the reasons why the power-based systems seem to have done better defending their market share than some others. After relocating back to mainland Europe after my time in the UK, I found quite a few systems that customers ran were still based on power. SPARC has suffered in the past from low performance per dollar. This has changed recently with the release of the T5s and the M5s, and at this open world the successor of these systems has been officially introduced to the public, and these systems seem to pack a lot more performance, and even more crucially they have a lot of memory that you can use to run your workloads on. So I've seen a little bit of a decline with SPARC, but they seem to be bouncing back over the last couple of years or so. What I'm really sad to see, though, is that AMD and their Opteron processors, they seem to be really disappearing. It would appear that the change from the previous architecture over to the new bulldozer architecture introduced with the, I think it's the AMD 6200 Opterons, has really hurt the single-thread performance. And in my career, I found that single-thread performance in Oracle databases is really what the most crucial factor is, and by single thread performance I believe that there are very few processors that really stand out, and the Intel processors certainly do. Okay, so why have these Unix platforms lost market share? So the majority of workloads is probably okay with a 2 or 4 socket system. And if I remember back, the first N-way system, where N was 4, that I looked at, they were all Unix. And at the time, the Intel or AMD processor just weren't up to it, and it took them quite a few years to come up to speed and become competitive with those systems. And another factor why the established Unix platforms are losing market share is simply because they're expensive. If you consider single thread performance on an x86-64 system with a traditional Unix processor, then the x86 platform is probably up to speed and more than capable to take over workloads that were previously running on those more expensive platforms. And there's also the Oracle core factor that plays into it. Some platforms are penalized with a higher core factor, and so it's not only the hardware that costs you a bit more, it's also the licenses for the Oracle Enterprise Edition that costs you more. In addition to that, the x86 world has really caught up with the traditional Unix processors that allowed you for a lot of reliability, availability, and serviceability, called RAS features. It's not only the processor, it's also memory, it's I/O, and the system overall. And for example, the largest memory available with the E7 Xeons that you find, for example, in the Exadata X38 is 2 to 4 terabyte per node. The X38 packs 2 terabyte, but I've seen a benchmark with a similar system that took 4 terabyte of DRAM per node. The current Xeons, well, the previous generation Xeons that you find, for example, in the Exadata X32s, they were the E5 Xeons based on the Sandy Bridge architecture. They were allowing you to pack a reasonably formidable package into a system, but the current Ivy Bridge based Xeons that you see mentioned here, the largest system that you find on the Intel website for Xeon EP, so a dual socket system, would be 2 sockets, 24 cores, and 48 threads, which is quite amazing. And if you add the addressability of 1.5 terabyte memory on a 2-socket system, then you can see that some of the advantages of the traditional Unix platforms, large memory, lots of sockets, lots of cores, are shifting towards equilibrium where the Intel world has caught up. The current Opterons that I found, they do pack 16 cores per socket, but they're not real cores. They're a hybrid between a core and a thread, so they're not real cores and not comparable with the EP system. So their single thread performance is lower. By comparison, the current E7 Xeons, the up to 8-way Xeons, give you 10 cores and they give you hyper-threading, and it is quite impressive to see the number of threads in the top output when you run it on an Intel on a Linux system. RAS features, like I said, are not as important as they were. There are other solutions outside of the machine where you can compensate for reliability of your hardware. So what does it mean? Because of everybody has to save money and cut cost, many organizations are revisiting their standards. New building blocks are emerging. There are also new technologies outside of the database server, such as flash memory, and these all make their way into the future hardware reference platform, especially when you're thinking about consolidation and database as a service, and that's DBaaS here. Some systems that really do this well is Oracle's engineered systems. For a database workload, they would obviously be Exadata or its smaller cousin, the database appliance, even though they are not made for the same purpose. The other option you have is obviously to create your own system, but then it's your responsibility or your engineering department's responsibility to ensure that your driver stack, the kernel and the database version and everything are compatible. Well, after all that introduction, I think all I want to say is that you will be moving systems to Linux soon. But don't be scared by the penguin. It's a really useful and great operating system. So migrating strategies to Linux I will cover next. So that includes Exadata too, obviously, because Exadata, after all, is based on Oracle Linux. Which strategies do you have in your arsenal? What can you do when you want to migrate to Linux? So first of all, the strategy depends on the source platform. It is quite easy, or it can be easy, if the data encoding remains the same. And data encoding here, we're speaking of the so-called Endianness. There are basically two different Endianness formats. One of them is big-endianness, where you see SPARC, AIX, HPUX, basically those platforms that were standard a few years ago, but which are now being, well, how should I say, being migrated off at a larger scale. Little endian platforms, on the other hand, would be Linux and Windows, and I'm not saying Windows Itanium here, I think that has been discontinued, but anything based on the x86 Intel Xeon processors, or AMD for that matter. Endianness, when I looked this up, because I wanted to have a good description of Endianness, I looked it up, and even in Wikipedia it says the term is based on Jonathan Swift's Gulliver's Travels, and apparently Gulliver comes to an island and he talks to people, and there are different people. Some of them eat the eggs with the little end, and some eat the eggs the big end first. And yeah, I found this quite amusing that this term has made it into computer science, but here we mean the byte order in a word. In a word is a structure in memory. So the first option is big-endian, and in big-endian we store the most significant byte in the smallest address. And little-endian is the inverse, so you store the least significant byte in the smallest address. And this can cause conversion problems. In essence, it means if you write a text file on a big-endian platform and you want to read it on a little-endian platform, it is reversed, and it doesn't make sense. And this is the same for anything that's encoded. So the endianness needs to be adapted before you can make sense of a file created on a different endianness platform. It's actually the same with networking. When you using network protocols to copy things from, say, from AIX to Linux, then there is implicit endianness conversion already built into the networking stack. DataGuard. DataGuard is one of my favorite technologies. So in a nutshell, DataGuard allows you to ship changes that have been made on a primary database or a database running in the primary role to a number of standby databases. And the physical standby database, which is probably the most common, just simply applies the redo information as it comes from the primary database, and in this way it keeps the standby and the primary database in sync. Now, when I started with DataGuard and looking at DataGuard, it was not possible to have different platforms in a DataGuard configuration, but now there is something that's called heterogeneous DataGuard, and this can really be a solution to a migration problem. There are two My Oracle support documents that are really interesting from this point of view. Physical standbys are explained in note 413384.1, as you can see there, and it explains DataGuard, different platforms, and the most important bit there is a table that lists the current platforms that the DataGuard technology supports in a matrix, and it says, for example, this combination is possible or this other combination is not possible. And for most of them, it is true that there is not really a heterogeneous data guard configuration. I didn't really look into the logical standby node that's referenced here as well in 10.85.68.1, simply because I have seen very few systems that use logical standby. There seem to be more restrictions around the way that a logical standby handles is treated in a situation where you've got different platforms. So I didn't look into it in too much detail. What's interesting though is that DataGuard supports some 32-bit to 64-bit combinations. So if you're still on 32-bit, you could even use DataGuard to go from, say, Linux 32-bit to 64-bit, even though by now this is probably a very uncommon situation. I've listed some possible DataGuard combinations on this slide. I would ask you to double check with the My Oracle support document. Even though it hasn't changed for a little while, it's still good to have a look at it to see if that's still valid now. But for Windows, we see that you can have mixed 32-bit, 64-bit, and even based on the Endianness architecture. But that doesn't really have a practical relevance these days. Linux, the same thing, 32-bit, 64-bit, including Endianness, even though, again, with Endianness that has very little practical relevance at the moment. HPUX, you can mix PA-RISC, which has been replaced with the Endianness processor, so you could use DataGuard to migrate off your PA-RISC HPUX system and onto Endianness. A very interesting bit there is that ARX and Solaris on SPARC, where somebody must have requested this, and there is an enhancement request in that Bach that's referenced even in that My Oracle support note. But currently there's no movement on it. But it would be interesting to see if you could use ARX and SPARC and use them in a DataGuard configuration. However, there are certain restrictions that you need to adhere to when you are planning on using DataGuard with different platforms. These are all outlined in My Oracle support, and there are just too many combinations to mention them here, so I recommend you to have a look, see if your combination that you're interested in is possible, and if so, if there are further nodes that you need to look at and see how you do the initial restore of the database on your destination platform and how you do the role change. So if you've checked that matrix in either of those two My Oracle support nodes, and you find out that actually DataGuard is not an option, then you have more options at your disposal, and many of us have looked at those. In 11G, these include Recovery Manager and transportable tablespaces. So this is one often used approach, and I've used this quite a few times to migrate even larger data sets. And this is one of the technologies that has been enhanced, and I'll talk about those a bit later. DBMS file transfer is possible as well. It seems to convert Endianness on the fly, so that's interesting, but files must be smaller than 2 terabytes, and it doesn't really handle Oracle managed file names terribly well. Then there is the option to use logical export and import, and by those I mean the export data pump and import data pump. However, with the data volumes that we are usually looking at, that is just not an option, because it would take too long, or it would be too difficult to use export import in many cases to migrate the data across in a reasonable downtime window. And last but not least, you've got replication technologies. Golden Gate is now the favorite replication technology by Oracle. Before the Golden Gate acquisition, you could have looked at streams. And there are, of course, others, third-party products that allow you to replicate data from one database to another. Now, probably the quickest way to migrate large data sets from one platform to another is using RMAN to convert from, in this case, big-endian to little-endian, because it's a talk about migrating to Linux. So how does that happen? It is quite simple in theory, and it involves a few steps. First, you set the tablespace read-only on the source. Then you export the tablespace metadata from the source, transport files to destination, create necessary metadata in your destination database, so users, grants, anything that is not on the tablespace itself that you're moving, like stored procedures and other things. Then, after the conversion to the destination platform has completed successfully, you import the tablespace metadata to the destination, and finally make the tablespace available for reading and writing. And this is the process that you'd have to follow unless you use fancy storage technologies, but since not everybody has them available, I haven't mentioned them here. There are ways to shorten this process. However, it requires you to have a downtime window, because here at the beginning you have to set the tablespace read-only on the source, and it's only when you make them available for reading and writing on the destination that users can actually write to the application again. Okay, so that sounds simple. Let's do it then. It sounds possible. There are a few complications you need to be aware of. You can't simply take a tablespace from, say, AIX and plug it into Linux because of the before mentioned Endianness conversion problem. Also, tablespaces must be self-contained, and there are certain restrictions around transportable tablespaces that I'll cover in a little bit. Not every object cannot be transported on a transportable tablespace. So you very often have to convert the data files before you can plug them into your destination database. But there is the problem. While you're doing this, so there are two steps. You put the tablespace read-only, you ship it to where it's going to be planned to be plugged into, which can take time, especially if you're thinking terabytes of data, and only then can you migrate the tablespace to the different Endianness platform, which might also take time. And that means that you have downtime during the migration. And to quote Moens Norgans, I would like to say we do not use a lot of downtime if we can avoid it. So now there is the new way of doing it. Is a potential of reducing the downtime window considerably. It sounds a bit like a tongue twister, and when I first looked at it and I even got the title of this webinar wrong initially. It's actually cross-platform transportable tablespaces and incremental backups, and this makes for a fairly long title. But these two combined address 2 points. First of all, the need for extended downtime, and that is because the read-only phase can potentially be shortened, but it depends on your data set. And you may have less or probably even no need for replication tools for those things that you can't transport over in time. So it's cross-platform, incremental backups, plus transportable tablespace. But they do not help you in the following cases. If you're exporting a lot of metadata, and these would be any commercial off-the-shelf systems that create thousands and thousands and thousands of objects and users and grants. So the metadata in the dictionary is huge, and it would take a long time to export these. And there is a small caveat right now as well. This technique does not help you if you're not migrating to Exadata. So the document I will refer to in a minute says, and it has been updated in May for the last time, it states that this process is not supported unless you are migrating to Exadata. Okay, now one of the things that you need to know about the process is the use of incremental backups. And if I remember correctly, this incremental backup strategy that you see on this slide was the default backup strategy in Oracle 10G when you created DB console and Oracle prompted you, should I take care of the backups? And you could say yes. And it's a fairly simple but very elegant process. So first of all, what happens? Oracle 10 introduced the flash recovery area. At the time it was called flash recovery area. Now it's the fast recovery area, the FRA. So what this backup process does is you create an image copy of a data file. Say your database has 10 data files. You do a backup as copy in RMAN with the destination of the FRA. So it will create a one-to-one copy of your data files in the fast recovery area. This is the first step. Now you take incremental backups of your live data files, say every evening in the week. But the idea of these is not to roll forward the live database, but also to roll forward those image copies of your live database in the FRA. Say you took your image copy on a Sunday night, you take an incremental on Monday, you then say, hey, RMAN, roll forward those image copies in the FRA from Sunday, and it will do so. So you apply the incremental backup on the data file copy. The idea is simple. Instead of having to apply lots of incremental backups and potentially lots of archive logs to restore the live database, you have a reasonably recent copy of your database already restored, and you can save time restoring your database. The process that I've just outlined has been designed with the switch over to copy command, which is an RMAN command, in mind. So imagine you have got a catastrophic failure, and you could just then say, well, okay, I switch over to the copy of my database, apply the archive logs, and I save a lot of time on restoring. Okay, and all the time you're doing this, the source remains online and available. I say storage admins find this amusing because the same strategy, if I'm not very mistaken, or a very similar approach is taken on many enterprise arrays as well to keep things in sync. Okay, so bear this in mind. We will come back to those. Okay, so first of all, now when I first read about those, and I stumbled about, I found this note by accident, by reading the Oracle L mailing list, which I recommend you do as well. It's a very great place to learn about Oracle and ask questions to some of the industry's experts. So I came across this note and looked at it, and I thought, wow, this is really cool because it helps me a lot doing certain things. So the procedure is explained in this particular Docker ID that I've just shown here, 1389592.1, and it explains a process in multiple phases. So the first phase of this whole process is the initial setup, followed by a prepare phase, then a roll forward phase, a transport phase, and finally the cutover. So these all lead you towards the goal of migrating your system from, say, a big-endian platform into Exadata. Prerequisites. So what do you need? The whole process is more or less driven by a script which you download from this particular My Oracle support node. And it states, this node states that you need an 11.202 plus bundle patch 12 home on your destination system. In this, you install a few overlay patches, like the 133.40675 for the core functionality of this. And if your source contains indexed organized tables or IoTs, then you need to apply another patch. There may be others. Go back to the node and have a look if there are not different other nodes patches that you have to install. The process clearly states that it cannot overcome the limits of transportable tablespaces, and I promised you to mention some of those limits. First of all, tables with timestamp with time zone data types are difficult. Materialized views and the underlying table must be in the transportable tablespace or transportable tablespace set, or they aren't exported. There are certain restrictions around encryption, and you also have to have compatible character sets. So I suggest you have a look at the admin guide of 11.2 and read about certain other limits of transportable tablespaces. So this process is nothing new. It builds on the functionality that you already have. Then the source database needs to have the compatible set to greater than or equal of 10.2, it must be in archive log mode. So I would be very surprised if if the source database wasn't, but it's explicitly stated again. You should not have your backups set to compressed backups for device type disk, and you must not have offline files in the tablespaces that you want to migrate using this technology, and the tablespace must neither be read-only. Okay, so now that if you're happy that you meet those prerequisites, then it is time to do the initial setup. So with the initial setup, you download this set of scripts. At the time I wrote this presentation, it was RMAN XTT convert 1.3 from the My Oracle support notes I just mentioned. You download it to home Oracle or wherever your Oracle home is on your source. Extract it. I usually use XTT for these, and then you edit the main configuration file, which I will show in a minute. In this configuration file, you define certain locations where things are to be stored, and you need to create those directories, otherwise the process will fail. And once that's done, you take the whole XTT directory and copy it to the destination. And thanks to Andy Colvin, I now know about the scp-r flag, which allows me to copy a whole directory recursively to a different host. So you just scp-r home XTT to the Exadata system you're migrating to. Then on the destination host, you create the incremental database software home as described. So it is this 11.202 plus bundle patch 12 plus these overlay patches. Then you create a minimalistic P file, start the instance in no mode, and that's it. You create or you identify the software home for the destination database, and that definitely shouldn't be 11.202 right now. It should be 11.203 or later. Define the database to import the tablespaces to. So if it's a consolidation database, you identify the database where you want to import those tablespaces into. And then you apply any other patches that you have to if the Oracle RDBMS home is a new home that you're creating. Apply the quarterly database patches for Exadata and any overlay patches that you may need. And again, just as on the source, there are a certain number of directories referenced in the xtt.properties file that you need to create as well. So let's have a look at my demo system. So I do have a system with a database that I wanted to call big-endian, but as you can see, it's only big-endia. So there was the restriction on the length of the Oracle SID that has bitten me. But this is a system that is running on Solaris. I have created two users which store their objects on two tablespaces. So the first user is MBH1, the second one is MBH2. I've got two tablespaces with the same name, and they've got two tables on there. Okay, and I want to migrate the users and their tablespaces over to a system that runs on Linux. And there is an 11.203 database on this system, which is called Little. I mentioned the xtt.properties files, and this is the one I'm using for the demo, and I've stripped all the comments out of the file. There are lots of comments that really make it simple for you to actually fill the values in. This is for my demo environment. This is not for the Exadata environment. Okay, so I've got two tablespaces, MBH1 and 2. The platform ID you get from the $database from your source. In my case, that's Solaris. dfcopydir is the data file copy directory. So this is where you will create the image copies that we're about to create. So it has to be big enough to take an image copy of all the data files for those tablespaces that you mentioned over here. It can be NFS. But if you're using NFS for RMAN backups, be aware that there are certain mount options that you have to respect. Backup format as the next one. So this is the location on the source where the incremental backups are created. So we'll take image copies first, and as we would have done with the incremental backups that I presented a few slides earlier, you take incremental backups and store them on backup format in that directory. Stage on dest is then where the files that we have created, the incremental backups as well as the data file copies, will be on the Exadata. So this can be dbfs if you would like to. Storage on dest is the location on the destination system where the data file copies are stored later on. In my case, it's a file system because I don't have an ASM instance, but in the real life example, it would definitely be the data disk group on Exadata. And then finally, we've got backup on dest. That's important. This is the location on the destination where the converted incremental backups will be written to during one of the steps I'm about to explain. And this will be RECO, the RECO disk group in Exadata. And finally, there it references the convert instance home, which, as you can see, is 11.202, as I explained, with bundle patch 12. And the SID for the convert instance is XTT. And for me, I set the parallelism to 1 not to kill the virtual machines, but in reality, the parallel parameter in here defines the RMAN degree of parallelism when it performs this task. So in real life, it would obviously be more than 1. Additionally, in Exadata, you will need to specify the ASM home and the ASM SID as well in this file, but since this is not applicable in the demo environment, I don't have them here. Okay, so now the first step is to run the prepare phase, where we create the data file copies locally to the directory indicated by the df copy dir. It does validations and sanity checking a little bit, but not exhaustively, so this is your responsibility to check. It creates 2 files that it will need later, xtt plan and RMAN convert. So let's see if I can get this to work. I need to exit here, I need to move into XTT, and now if I run this command, it should start the prepare phase. And as you can see, it's preparing for the tablespaces I mentioned, and they will later on be put into U01 XTT stage dest. So they're not yet there, they go into the corresponding directory on the source system. This will take a tiny little amount of time. It's 2 data files of 50 meg each. Okay, seems to have finished. Now if I look into the U01 XTT stage source directory, you see it's done the image copies. Now it's actually 20 meg per data file. You see them here in the source. Now that's the first step. xtt.driver.pl is the main script that we are using in this process. Here is the output again. I'll skip because the demo seems to be working. So the data file copies now need to somehow reach the destination. Either use NFS, so you could have had an NFS mount, or you need to copy the files. In my case, I SCP the files because they're tiny little files. The note specifically states you can't use ASM-CMD or DBMS file transfer here. And once the files have been copied over to the destination system, you need to run the convert step. So this is pretty simple. Let me show you this. So still on the source, now I'm copying all the files over, the 2 image files, and some metadata as well. Okay, now that they have come across to the other system, I change into the XTT directory and run the convert, which is xtt driver.pl with a C option. it expects the files to be in a specific location, and this location you indicate in the XTT properties. So what's in this file here? So you see tablespace name, data file name, and this is the location where the file will eventually end up being plugged into the database. This would be plus data on an Exadata system, but since my laptop isn't an Exadata, I have it on a file system. Okay, so the data files will be created on the storage on dest. So this location I just shown you is storage on dest. So again, the output. Here's the RMAN conversion script, and just to show you that there is nothing very special about it. So it just takes the data file and converts it. You see, you don't need to, first of all, don't touch this script because it's generated by the process. The format clause is based on the storage on dest parameter in the XTT properties. Parallelism is also a parameter, so parallelism 1 is just fine for my system. So what's happened? We've got an initial copy of the tablespaces. The data file copies are on the destination and they are converted. What's nice about the fact is that the source system was online all the time. We did not say alter tablespace name, read only. So this is cool. First step done. Keep calm and carry on. Now we roll forward. So the source system ticks on, you know, it's Monday, Tuesday, Wednesday, and we take incremental backups of the source tablespaces. So you take the backup, transport the backup to the destination, you convert the incremental backup, apply to the data file copies, and this is where the magic is. And this you repeat as often as you like, just to the point where you're very close to production, which would probably be during the weekend. And once you're happy that you're reasonably close to production, you cut over and continue with the transport phase. Okay, so we first take an incremental backup. Back to my code. First of all, just to show you that it actually does work, I run an update. So I'm updating the table and I'm setting the owner to modification 1, just to simulate some activity. And I do the same with the second table. At the end I commit. Commit faster. Okay, now back to the XTT directory. I take an incremental backup. It'll not show the output until the command has completed. The incremental backups will be saved in U01 XTT stage source once that's completed. And it takes a little bit of time. Okay, it's done it. Now, if I look into that directory, you will see my 2 data files plus the incremental backup things. Now, there are a few commands I need to execute to get those over. And there is some metadata to transport as well. So those 2 files are important. Okay, so I have now simulated activity, and I've also copied, I've taken a backup, so the incremental backup is as current as my database is now. Now I need to roll my data file copies forward. So this information, the reason I've copied those 2 files over is because they contain information needed for the roll forward. So back on my system here, I use the -R to roll forward. which is quick. Okay, it's done it. And finally, I need to get the next SDN for further backup. So back on the source system, I need to run the XTT driver script with the S flag. Oh, that sounds dodgy. So back in home, XTT. Okay, it creates a new file, so this has the latest SCNs in it. Okay, back into PowerPoint. So what you will see there is the data file number as well as the table space name and the current SCN. Now this process you repeat as often as you like. Then you make the decision to cut over, and you go from the row forward into the transport phase. And this is where you will encounter an outage because, like I said, it's only to shorten the outage, not to remove it. And it depends on how much metadata you have got to copy. In the meantime, make sure you've got all the users and grants in the destination database. Okay, so this is identical to the process before. You make the table spaces on the source database read-only, create the final incremental backup, ship it over, including the required files, roll forward and recovery on the destination, import the metadata, validate table spaces, make them read-write, and be happy because you've just done something cool. Okay, so here we go. I'll just simulate another modification. So I say pre-cut over, just to show you that the process actually does work. So that will update my tables again and commit at the end. And now somebody has said, okay, we are ready, we want to migrate. Well, once that's committed. Okay, so we want to migrate now. Go, green light. So I put the table space read only, the first one. No, don't fail me now. Okay, table spaces are read only. Now I need to take a final incremental backup. It's the same as before. Exit into XTT incremental backup. That should not take too long, hopefully. I'm conscious of the time, obviously. Bear with me, we're nearly there. For those of you who have to drop off, feel free to have a look at the recording afterwards. Okay, so it's done it. Now I need to use these commands again to copy the files that have just been created, and I need the meta information as well. Just as before, I need to roll my database forward. And now I need to create the users. And I also need to create a database link, and you will see in a minute why we do this. Okay. So the metadata import, when I did this the last time, it really hurt because you need to create a data pump command similar to this one. And what's really cool is that the script using the -e command will create all of this for you. You just need to fill it out. So what you do is you change it to your needs and run it. It's the same as you would have done with transportable table spaces before. So it's nothing different. I have actually worked a bit here, created a script to do this. So I've got an imp sh. So it does import data pump. It uses the data pump directory with this log file, that database link. Transport tablespaces as we want. Data files are mentioned here. And if everything goes well, it should now import all the things that we have exported. It's of course a simplified example. There would be more objects and more grants and more users and more dependencies to work on. But you know, the idea is the same. Okay, woohoo, it's done it. Finishing touches, right? Okay, before you say woohoo like I just did, you run RMAN validate tablespace, check logical. Only then do you make the tablespaces read write, and you test. Then you have somebody sign off, and then you have a beverage of your choice. So let's do those quickly. So we stay on the destination. What's the status? Okay, my users exist. My tablespaces exist, they're available and online. Okay, first hurdle taken. Now, I want to make sure that everything is correct and I didn't have any corruptions. So, validate tablespace, tablespace name. Hooray, blocks failing 0. Next. Blocks failing 0. Okay, so that seems to be okay. Now I do alter database. No. If I don't copy paste alter tablespace. Tablespace is read write. Now the final thing to run is I'm selecting the owner from these tables, and you see it's taken modification pre-cut over, so it's not stuck halfway in between. And that's it. The references here, there are master notes for transportable tablespaces that you should consult, especially when it comes to limitations of the technology. And there is the cross-platform incremental backup transportable tablespace master note as well, which for me is the end of the presentation. I've seen quite a few questions, so I'll hand over to the Q&A section right now.
Hi Martin, thank you for going over the session. I hope everybody enjoyed it. We've had some good questions in and some feedback as well. So thank you everybody for sending this over. I do hope you enjoyed it. I'm just going to quickly go through the list of questions and organise them so that I can put them to you, Martin. Please bear with me whilst I do this. It'll be only a few seconds. Whilst you're waiting, please just note down the sponsors' website, so redgate.com/Oracle and Enkitec.com. And if you have a browser open with Twitter, please do follow us and feel free to tweet your feedback. Okay, so the first question, Martin. Question, to your knowledge, does this work on non-Exadata, just not supported, or is there a hard check where it doesn't even work?
There is no hard check, no, but it's not supported. When I last presented this, and the reason for you seeing UK or UG as table names, I presented this in June before 11.204 was out, and I was told then in the Q&A section that this process is likely to be extended to 11.204 and supported for non-Exadata as well. But as it stands now, the note is updated last May this year, and it says clearly currently only supported on Exadata as the destination. But if you Google, you will find people have done it out without Exadata as well.
Fantastic. And there's a question that kind of links to this. Have you done any testing on 12C?
Not with this, no.
Okay, next question. Can the source system be on 10.203 to take incremental from 10G and apply on 11G?
If it says the restriction, if I'm not mistaken, is that compatible has to be 10.2. So I suppose a 10.2 database would be eligible as well.
Thank you. A question here. Does the source database always have to be the primary database? And there's a little bit of context to this. We have long moved backup operations from our primary database to one of our standby databases.
Oh, well, this is not necessarily data guard related. This procedure is for taking tablespaces from a live system and migrating them into Exadata.
Okay, thank you.
I hope that answers the questions.
If that doesn't answer your question, please do add it in again. There are a couple of people asking about sharing the slides. So Martin will make the slides available as well as the video that can be downloaded from the Redgate website and also from the Enkitec website, and I'll include links in the follow-up email to that. So we've got a question here, again relating to support for Exadata as a target. Do you know of any technical reasons why this toolset method is only supported for Exadata as a target?
Well, I'm not working in support, so I'm sorry I can't tell you.
Okay.
But I'm hoping it'll be available for others as well. But as it stands, it's not.
Mm-hmm. So there are a couple of questions which are quite specific to individuals' environments. Martin, I think I'll send these questions here. You might see one of them at the moment that's to do with 3 databases that need to be migrated. Hopefully we can send a follow-up to that afterwards. Unless there's something that you would be able to help out.
Yeah, just email me. Let me just see. But yeah, send them through. We'll reply offline.
Fantastic. Next question, does logical export and import utility take care of Endian conversion?
It should.
Okay. Thank you. And the next question here, would you suggest to use a transportable table space with a relational database upgrade scenario?
Well, that very much depends. I'm normally a friend of running the upgrade scripts on the database, but I'd have to check. It's quite simple to see. If you have to look at the documentation set, the upgrade guide, and if it says transportable tablespaces are supported and are a valid method, then yes, it works. I don't know off the top of my head if that's a valid upgrade path. I'd have to check.
Thank you. Okay, so there's a little bit of extra context to that question, that was plugging a table space in a new release of the database.
In new release, I just saw it.
Yeah.
Yeah, I suppose it works.
Fantastic.
and but the My Oracle support note I mentioned has a lot more detail about what it supports and what it doesn't, and it references to that master node of transportable tablespaces. And I guess it depends on your environment if it does work in the end or not. So I always recommend checking the metalink nodes, and if there are uncertainties, raise a service request with Oracle to make sure that what you're planning is what they support, and that you're covered from this angle.
Great, thank you. Next question here, can we export from AIX and import into Linux?
I suppose that's export, yes. Yeah, no, like the traditional export data pump, export utilities should be able to do this.
Fantastic. And we've got another question here. Do you have any tips on how to speed up a metadata import?
No, I don't think there is any way to do this any quicker. There's only one set of commands that you do, and I do believe they are treated sequentially, and I don't think it can be sped up. But I wish it was, and I stand corrected if it isn't, but not to my knowledge.
The next question here, is there a limit on the number of table spaces in a source database?
Yes, there is. There is in the control file, and there is in the initialization file parameters. I think it's called max data files and so on, but there are definitely limits. Yeah, it's one of the things I have come across with a system where I migrated using transportable tablespaces, and it turned out that the destination database had the settings for the maximum number of data files too low, and that is a serious problem, and you should definitely check beforehand before you import into your destination that you have enough slots available for your data files. Especially with older systems which have been created with data files not larger than a certain size, you end up with thousands of data files, and you try to plug them into another database. It might be that you don't have enough slots available, and it will create you an error which is not easy to recover from. Well, it is possible, but it's unpleasant. And this is why this procedure needs testing. So don't just do it with a live system. Test before you actually do it.
Thank you.
How to recover metadata failing? I think I did a restore of my shell database. It was an empty database. I imported those data files in, and I started looking at grants and dropping and revoking, and I thought this just takes too long, and I created a new shell database to import into with the correct number of slots, and it worked.
Thank you. Okay, so we've reached the end of the Q&A. I hope we were able to answer all of your questions how you wanted to. Once again, you will be able to ask further questions, either directly contact Martin via Enkitec or at Martin DBA. And of course, there is an article published on allthingsoracle.com for this webinar as well. So if you want to leave comments, you can leave comments on there. Once again, this session has been recorded, so I will send round an email to everybody afterwards to let you know where you can download the copy of the slides, and also where you can watch this video on YouTube. So just like to finish off to say thank you to everybody for joining us today, and thank you to Martin for taking us through that session. I hope you've all enjoyed it as much as I have.
Thanks, everyone.
Thank you, and have a good evening or a good day depending on where you are in the world, and I look forward to seeing you at the next webinar. Thank you. Bye now.